All right, so now we're on lesson 1.1.3, recognizing functions and function families, day 2. Yes, it's the same day, but you know, we have a weird schedule this year, so I guess we just gotta deal with it. So let's get on to the vocabulary. Function notation. Let me write it out. Function notation is a way of representing functions algebraically. Okay, so it sounds kind of intimidating, but I want you to think back to last year. You guys have probably seen equations before. For example, y equals 8x plus 15. Let's just say this is an equation, right? You've seen stuff like this before. However, if you want to write it in function notation, then you write, instead of y, this just switches to f of x is equal to 8x plus 15. So let me highlight that this is the function notation. Function notation is this one, okay? The first one with the y, that's just a plain old equation. The second one with this f parentheses x, that is your function notation. Now, how would you read this f parentheses x? You read it as f of, oops, why is it not writing? Of x. That's how you say it, f of x. And then you know how to say equals 8x plus 15. So I only wrote the f of x part, okay? And the f stands for function. And the x is your independent variable. Remember, we learned about independent and dependent variables. This is your independent variable. Or quantity, you can call it a quantity. I'll just call it quantity because that's the word we were using before. So that's your independent quantity. And f is your dependent quantity. I'll just write depends on x because your dependent quantity depends on your independent quantity. So f depends on x. That's why it's called f of x, okay? And you don't always have to use the letter f. You could also write, let's just pick another letter. I'm just gonna pick the letter c. You could write c of x is equal to 8x plus 15. So c depends on x. You know, you can also pick another letter instead of x. You can use c of s is equal to 8s plus 15. So in this case, it would be c depends on s. All right? So all of these are function notation. Let me highlight them all. This is also function notation. This is also function notation, okay? So you have many different options for function notation. You just don't write it with the y anymore. You just replace the y with letter of letter, f of x, c of x, c of s, whatever you like. Okay, so now let's take a look at our examples. So determine which relations represent functions. If the relation is not a function, state why not. So I want you to remember that a function should have only one output for every input, okay? So let's do example number 1. So let's see. Negative 3 has one output of -6. -2 has one output of -4. -1 has one output of -2. 0 has one output of 0. 1 has one output of 2. So far, we've only had one output for every input. So this is a function. Okay, now let's take a look at number 3. I'm gonna guide you through this one also. 3 goes to -6. Okay, that's one output. 3, oh wait, there's another 3. Does it also go to -6? It goes to -4. So 3 has -6 as a boyfriend. 3 also has -4 as a boyfriend. Look, 3 also has -2 as a boyfriend. 3 also has 0 as a boyfriend. And 3 also has 2 as a boyfriend. Is this a functioning relationship? No, 3 has too many. This is not a function. So the input of 3 and where do I have space? The input of 3 has more than one output because it had the output of, let me highlight, it had the output of -6, it had the output of -4, it had an output of -2, of 0, of 2. That's more than one, right? There's 5 of them total, so this is not a function. All right, so now we'll pause, let you guys work on number 2 and 4, and then, actually we'll not pause. I'll let you guys work on the right half of the page later on. Okay, let's get through our examples some more. Let's go on to number 5. So number 5 has a mapping, like a picture. So we can take a look to see if every input, which is the stuff in the domain, has only one output. So let's take a look. 1 has an output of 2, okay. 4 has an output of 5, okay. 4 also has an output of -5. Is that a function? 4 has 2 boyfriends. This is not a function. Because the input 4 has more than one output. Okay, that's not a function. Let's take a look at number 7. Look, it looks so messy, right? But it's okay, we'll figure it out together, don't worry. Let's start with the domain and let's see how many outputs it has. -4 has 11. -1 has 14. I'm gonna switch colors because this is getting messy. 0 has 11. And 3 has 2. Why does it look like that? Come on. Okay. So, what do you guys think about 11 belong to -4 and 0? Technically, this is okay. This is still a function, guys, because -4, everything in the domain, -4 and 0, they only have one output. -4 has the output of 11. 0 has the output of 11. -4 doesn't have any other output. 0 does not have any other output. This is a function. Okay? So I guess if we're using the boyfriend analogy, this is kind of sad sounding, but this is still a function because 11's keeping it a secret. -4 and 0 don't know that 11's seeing both of them, okay? So this is still a function. All right, let's take a look at number 9 and number 11. Let's take a look and see if it's a function. Okay, back to highlighting. 2 goes to 0. Okay. 3 goes to 1. Okay. 4 goes to 3. Okay. 5 goes to 5. Okay. Every single input, so everything in the domain is your input, every single input only went to one number in the range. This is a function. All right. Let me see where I can find one. Let's do number 10, okay? So for number 10, let's start analyzing. 5 goes to 3. 6 goes to 2. 5 appears again. 5 goes to 5. Wait, so 5 is going to 3 and 5 is going to 5. Is this a function? No. That's kind of messy, but you can read it. Not a function because the input 5 has more, wow, my writing is getting worse, has more than one output. Okay? And so now I'm gonna give you guys time to work on the other problems, okay? So make sure you finish them, and if you don't finish it for homework, make sure you ask me if you have any questions.